Welcome to Section 1, the backbone of buildings, lumber, and construction. From the sturdy frames that define a house's structure to the intricate details of its interior, lumber has played an essential role in building construction for centuries. This versatile material derived from trees provides both strength and aesthetic appeal. Understanding the different types of lumber, their production, and their environmental impacts is crucial for both builders and homeowners. This exploration into the world of lumber will delve into the characteristics, production processes, and sustainable practices associated with this essential building material. We will examine the different types of lumber, including softwood, hardwood, and engineered wood, highlighting their unique properties and applications. By understanding the journey of lumber from forest to frame, we can make informed decisions that balance our construction needs with environmental responsibility. This knowledge empowers us to create durable, beautiful, and sustainable structures for generations to come.
Welcome to Section 2, Softwood, abundant and versatile. Softwood lumber, derived from coniferous trees like pine, fir, and spruce, is the workhorse of the construction industry. These trees, characterized by their needle-like leaves and cone-shaped seed pods, grow quickly and abundantly, making softwood a readily available and cost-effective building material. Softwood lumber is prized for its strength-to-weight ratio, making it ideal for structural framing, joists, and rafters. Its abundance and affordability also make it a popular choice for sheathing, subflooring, and other construction applications. However, softwood lumber is generally less resistant to decay and insect damage than hardwood. It also tends to be more prone to warping and shrinking, requiring proper drying and treatment to ensure its long-term performance in construction.
Welcome to Section 3, Hardwood, Strength and Elegance in Home Building. Hardwood lumber derived from deciduous trees like oak, maple, and cherry is prized for its durability, strength, and aesthetic appeal. These trees, known for their broad leaves that change color and fall off seasonally, grow slower than conifers, resulting in denser, harder wood. Hardwood lumber is commonly used for flooring, cabinetry, furniture, and other applications where durability and aesthetics are paramount. The unique grain patterns and rich colors of hardwoods add warmth and character to homes, making them a popular choice for interior finishes. However, the slow growth cycle of hardwood trees makes them a less abundant and more expensive resource than softwood. Sustainable harvesting practices and responsible forest management are essential to ensure the long-term availability of these valuable species.
Welcome to Section 4, Engineered Wood Innovation for Sustainable Construction. Engineered wood products such as plywood, oriented strand board, OSB, and glulam beams represent a modern approach to lumber production that prioritizes both performance and sustainability. These products are manufactured by binding together wood strands, veneers, or fibers with adhesives under heat and pressure, creating strong, stable, and dimensionally consistent building materials. Engineered wood products offer several advantages over traditional lumber, including greater strength and stability, resistance to warping and shrinking, and more efficient use of wood resources. They can be manufactured in larger sizes than traditional lumber, reducing waste and installation time. Moreover, engineered wood products can utilize wood from smaller, faster-growing trees, reducing the reliance on old-growth forests. This makes them a more sustainable choice for construction, contributing to responsible forest management and reducing the environmental impact of the building industry.
From forest to framing, the journey of lumber production. The journey of lumber from forest to framing involves a series of carefully orchestrated steps that transform raw logs into usable building materials. This process begins with the harvesting of trees, which is typically done using sustainable forestry practices that minimize environmental impact. Once harvested, logs are transported to sawmills, where they are processed into lumber of various dimensions. The sawmilling process involves several stages, including debarking, primary sawing, edging, and trimming, to produce boards that meet specific size and quality standards. After sawmilling, lumber undergoes a drying process to reduce its moisture content, enhancing its stability and preventing shrinkage and warping. The final stage of lumber production often involves treatment with preservatives or fire retardants to enhance its durability and performance in different applications.
Sawmilling. Transforming logs into usable lumber. Sawmilling is a crucial stage in lumber production, where logs are transformed into usable boards of various dimensions. The process begins with debarking, where the outer bark of the log is removed to improve lumber quality and reduce wear and tear on sawmill equipment. Next, the log undergoes primary sawing, where it is cut into thick slabs called flitches using large automated saws. These flitches are then edged to remove the rounded edges, creating rectangular boards. Finally, the boards are trimmed to their final lengths, removing any defects or imperfections. Modern sawmills utilize advanced technology such as laser scanners and computer-controlled saws to optimize log yield and minimize waste. These technologies ensure that each log is processed efficiently, maximizing the amount of usable lumber produced while minimizing the environmental footprint of the sawmilling process.
Section 7. Drying and treatment enhancing durability and performance. After sawmilling, lumber must be dried to reduce its moisture content, which can vary depending on the species and the time of year the tree was harvested. Drying is essential for enhancing the stability of lumber, preventing shrinkage and warping, and improving its overall performance in construction. There are two primary methods of drying lumber: air drying and kiln drying. Air drying is a slower, more natural process that involves stacking lumber outdoors with spacers between the boards to allow for air circulation. Kiln drying, on the other hand, is a faster, more controlled process that involves placing lumber in large ovens called kilns, where heat and humidity are carefully regulated. Once dried, lumber may undergo treatment with preservatives or fire retardants to enhance its durability and performance in different applications. Preservatives protect lumber from decay, insects, and moisture damage, while fire retardants slow the spread of fire, enhancing safety in building construction.
Section 8. Environmental Stewardship, Sustainable Forestry and Certification. The increasing demand for lumber has raised concerns about the environmental impact of forest harvesting practices. Sustainable forestry aims to address these concerns by balancing the need for wood products with the long-term health and productivity of forests. Sustainable forestry practices include selective logging, which involves harvesting only mature trees while leaving younger trees to grow; reforestation, which involves planting new trees to replace those that have been harvested; and protecting water quality and wildlife habitat within forested areas. Certification programs, such as those offered by the Forest Stewardship Council, FSC, and the Sustainable Forestry Initiative, SFI, provide a way to verify that lumber has been harvested from sustainably managed forests. These programs set rigorous standards for forest management and chain of custody tracking, ensuring that certified lumber meets strict environmental and social criteria.
Section 9. Sustainable Choices for a Greener Future. As awareness of the environmental impacts of construction grows, choosing sustainable lumber options has become increasingly important. By opting for lumber from sustainably managed forests and considering the environmental footprint of different lumber types and production methods, we can minimize our impact on the planet while still building durable and beautiful structures. Reclaimed lumber, salvaged from old buildings, offers a unique and environmentally friendly option for construction and design. By giving new life to old wood, we reduce the demand for newly harvested lumber and conserve valuable resources. Furthermore, exploring alternative building materials such as bamboo, straw bales, and hempcrete can further reduce the environmental impact of construction. These materials offer unique properties and aesthetic possibilities while promoting sustainable building practices.
Section 10. Building with Awareness, Balancing Needs and Impacts. Choosing the right type of lumber for a construction project involves balancing various factors, including cost, durability, aesthetic preferences, and environmental impact. By understanding the characteristics of different lumber types, their production processes, and the importance of sustainable forestry, we can make informed decisions that align with our values and contribute to a more sustainable future. When selecting lumber, consider the specific application and the required performance characteristics. For structural framing, softwood lumber offers a cost-effective and readily available option. while hardwood is often preferred for flooring, cabinetry, and other applications where durability and aesthetics are paramount. By embracing sustainable forestry practices, supporting certified lumber products, and exploring alternative building materials, we can create a built environment that is both beautiful and environmentally responsible. Building with awareness empowers us to make choices that benefit both present and future generations.